Let us see this problem. We are given a singly linked list and a value k. We need to reverse this linked list in groups of size k. For example, this is our input linked list. We are given head of this linked list and we are given k as 3. Our output linked list is this. We need to reverse it in groups of size 3 because k is 3. So first these 3 nodes are reversed. We get 30, 20, 10. Then these 3 nodes are reversed. We get 60, 50, 40. Right? And this should be our new head. We need to return our new head as an output of this function. This is our input head. So pointers needs to be changed and head also needs to be changed. Let's see this example. Here again we have k equal to 3, but linked list has one node less. So we first reverse these 3 nodes. We get 30, 20, 10. Now we have 2 nodes less than k. So we reverse these 2 nodes also. So if there are less than k nodes left at the end, we simply need to reverse the remaining nodes. So we get 50, 40 at the end. So 30, 20, 10 and then 50, 40. Let us see this example. Here we have a linked list of size 3 and k is 4. So this is similar to this case. We have less nodes than k. So we need to simply return whatever we have. So we return these 3 nodes. So if your linked list is of size n and if k is greater than or equal to n, then you need to reverse the whole linked list. Now please pause this video and try to write down a function that takes head of a linked list as an argument, k as an argument, does these changes to the linked list and returns the new head. So this is your new head in this case. Your function should be returning reference or pointer to this node. This was your input head. In this case, this was your input head and your function should return reference or pointer to this node. Let us first talk about the recursive solution. Before we discuss the recursive solution, it is strongly recommended that you refer the reverse of a linked list video. I have written modified code for reverse of a linked list. The modification that I have made here is it reverses maximum k nodes. So if you reach the null first, then it will stop. Otherwise, it will stop when it has reversed the k nodes. So it is same code as the iterative reverse. The extra thing that I have added here is a count variable which is initialized as 0. And this count has to be smaller than k and count is incremented here. So this loop is going to run k times if you don't reach the end of the linked list. And it's going to reverse the linked list. It's going to reverse the first k nodes of the reverse linked list. You may pause this video now. Try to use this solution. Try thinking in terms of recursion. Make a diagram using pen and paper where you reverse the first k nodes and then you recursively assume that your recursive call will handle the remaining nodes, reverse the remaining nodes in the groups of size k. Then how will you connect it? Once you've done the connection part, your task is done. So please pause this video now and try to write down the recursive code. Here is the idea for recursion. Here is an example linked list. K is 3. So we want to reverse these 3 nodes, then these 3 nodes, then we want to keep 70. So this is what we want as an output. And we want this node to be new head of the linked list. So first we reverse first k nodes using this code, right? And after you run this code in your recursive call, what will happen? These 3 nodes will be reversed. Your previous pointer or reference will be here. Your original head is as it is still at 10. And then you make a recursive call for the remaining nodes for next pointer or reference, right? After you reverse the first k nodes, you will make a recursive call for next. And let's assume that your recursive call works perfectly fine. If we have written the correct recursive code, then it's going to execute perfectly fine and going to handle all the remaining nodes. Even if there are hundreds of nodes, they are going to be reversed in groups of size 3 or k. So once we have done this part, we'll get this linked list, correct linked list. We'll get 60, 50, 40 and then 70. So we assume that this recursive code is going to perfectly work fine. And we'll get the head of this linked list as this. This is our rest head, right? Head of the rest of the linked list. And we have these pointers or references now, and we have rest head that we got after recursively calling for next. How do we connect all these? So we have rest head, we have previous, we have head. So which node is going to be your new head? Previous is going to be new head. If your linked list has k or more nodes, then in this problem, kth node is always going to be the new head of the linked list. For example, if k is 3 here, then 30 is your new head. You can notice that 30 is your new head. If k is 4, then 40 would be your new head. If k is 5, then 50 would be your new head. So if k is less than or equal to length of the linked list, we are always going to have kth node as new head of the linked list. So we'll return this as new head, previous as new head. This is sure. Now how do we connect these nodes? This node should come after this node, right? You can notice tens next is 60. So we are going to make hats next as rest head, and then we are going to return previous as new head, and our task is done. Now please pause this video and try to write down the complete code. Let us now see the recursive implementation. So the first part of this recursive implementation is the same that I wrote earlier. We reverse the first k nodes. After we have reversed the first k nodes in this example, here we have 1, 2, 3, 4, 5 as input list, and we want 3, 2, 1, 5, 4. After you reverse the first k nodes, you will get 1, 2, 3 reversed, right? These pointers are reversed or references are reversed. And then you have remaining linked list. So what you did, you made a recursive call for the remaining linked list by passing the next, right? So this linked list after the recursive call also got reversed in groups of size k. Suppose there were 100 nodes, then all those 100 nodes would have been reversed in groups of size k. So now you have this situation. So what you want is, you want this 5 to be once next. This is our expected output. So what we do is, we do heads next equal to rest head. And we want this to be our head of whole linked list. So we return previous. Previous is pointing to this node for now. So we return this and we get the new head. So we just talked about a recursive solution. The time complexity of this recursive solution is going to be big O of n, because we are traversing through every node and we are reversing it. The auxiliary space, however, required is n by k, where n is the length of the linked list. Because you will call for first k nodes, then it will call for next k nodes, then next k nodes, then next k nodes. So you will have nk entries in the recursion call stack. Now please pause this video and think of an iterative solution that works in theta n time and requires theta 1 auxiliary space. We mainly need to remove the recursion and do it in a loop. Let us now talk about the iterative solution. Let us first reiterate the fact, if k is smaller than or equal to number of nodes in the linked list, then kth node is always going to be head of your modified linked list. We have talked about in the recursive solution also. And if k is more than or equal to length of the linked list, then after the first pass, whatever is the last node of your linked list that you processed, this node is going to be your head, right? So whatever is the last node that you processed after the first pass, it's going to be the head of your linked list, right? So we are going to run multiple passes like the recursive solution, and we are going to maintain a Boolean variable first pass. If this first pass is true, then we are going to set the head of whole output linked list, right? And then we are going to set this is first pass as false, so that in the subsequent runs, this is never true and we never set head again. So head in this example is going to be 3, right? Once you run the first pass, your previous pointer or previous reference will be at 3. So what we do is, we change the head equal to previous, right? So this is about handling the head of the linked list and handling the first pass of the iterative solution. After the first pass is over, you set the head and then you change it to false so that subsequent passes never go inside this if condition. Now, how do we connect individual reverse linked lists? After the first pass, you will have these 3 nodes reversed. You will have 3 to 1. After the second pass, you will have 4, 5, 6 reversed, and you will have 6, 5, 4. Now, how do we connect these 6, 5, 4 with these 3 to 1? For that purpose, we maintain a variable called previous first. If you take a look at this setup, you are going to notice that whatever is the first node of the previous pass, the head of the current pass is going to be next of that node. For example, if you are at this pass, head of this pass is 6, right? Head of this pass is 6, which is denoted by the previous. And what was the first node of the previous pass? It was 1, right? So you can notice that first node of the previous pass has next as the head of current pass. Now, if you see the second pass here, how are these two going to be connected? You will reverse these two, 8, 7, and where will you connect it? You will connect it after 4, right? You will have the remaining linked list as it is, and then you will have 4, 8, 7. So where did we connect 8? We connected it after the 4. And what is the 4 node? It is the first node of the previous pass. So we are maintaining a previous first variable, right, that we set after we have finished the current iteration to the first, right? So we begin with first equal to current, and then we change previous first equal to first. And if it is not the first pass, then we make the head of current pass as next of previous first, right? So whatever was the previous first, the current head is going to be next of it. For the first pass, we don't want to do it because there is no previous pass before it. For the first pass, we want to set the head. For the upcoming passes, we want to connect head of the current pass with the first of the previous pass. For example, for this pass, previous first was 1. We connected the head after reversing. After reversing, we have head always in the previous. So we made 1 next equal to 6. And after we reverse this, we had in the previous 6, 8, and we connected previous first next equal to head. So this is how this iterative solution works. We run a main loop that runs while current is not null. Inside this loop, we have multiple passes. In every pass, we reverse the k nodes or we reverse the nodes while current does not reach null. If it is the first pass, then we set the head. If it is not the first pass, then there must be a previous pass. So what we do is, we make previous passes first node next equal to head of current node. Previous first next equal to head of current node. Current pass. Head of current pass is always previous. That we have learned in the iterative reverse of a linked list. After we do this, we change the previous first equal to first, and at the end, we return head of the linked list.